what we studied? What was the last thing that we studied in the last class? Ek bar bol do. We have to complete syllabus also today for weekend exam, for our PACE exam. Okay, Gyaneshwari, no problem. You can message me on WhatsApp. Mechanical equilibrium we completed. Angular momentum I think we were talking about. Angular momentum of particle we were talking about. Yeah. Srikar, you will get that in the group. Don't worry. Angular momentum of particle was over. I told you angular momentum of particle will be mv into r perpendicular. So, and your r perpendicular will be constant. If your r perpendicular will be constant, angular momentum of the particle moving will be always constant. So, this is what we studied in the last class. Now we will start with our next part. We will talk about angular momentum of, Sheila, that is correct, no problem, yeah. From mechanical equilibrium we will have syllabus, yeah, okay, for weekend exam. Now we will start with our part angular momentum of rigid body. You can write angular momentum of rigid body. Angular momentum of rigid body. Angular momentum of, we'll start with our part angular momentum of, homework I will send. Last class homework I did not send because more homework was not there. Today I will send. Today we will complete angular momentum, then I will give you more homework. Yeah, okay. So we will talk about angular momentum. You can write angular momentum of particle over. Now we'll start with angular momentum of rigid body. Yeah, angular momentum of rigid body. Angular momentum of rigid body. Yeah. So always remember, see how to define angular momentum of rigid body, how we write angular momentum of rigid body. Yeah, okay. So for example, assume I have any rigid body. It may be a ring, it may be a disc, it may be a hollow sphere, it may be a solid sphere. Yeah, okay. So assume I am having a rigid body, no problem. Yeah. And this rigid body will be rotating about some of its axis. This rigid body, assume this is a rigid body which is rotating about its axis with angular velocity omega. Assume one rigid body is there. This rigid body is rotating with angular velocity omega about a given axis. Yeah. And about this axis, this rigid body will also have moment of inertia. Of course, if it is rotating about axis it will have moment of inertia. So if a rigid body is rotating with angular velocity omega, if it has moment of inertia I, then angular momentum of the rigid body we write as L will be equal to I into omega. L will be equal to angular momentum we define. The way for particle we define mv into r perpendicular. For rigid body we define angular momentum of the rigid body. L will be equal to I omega. And always remember this L will be always along. L will be always along. Direction of angular momentum will be always momentum of the rigid body. L will be equal to I omega, and since omega is along axis, actually since your omega is along axis, L will be also along axis of rotation. It's an axial vector. You know all the vectors in rotation are always along axis of rotation. So angular momentum will be along axis of rotation. And many times I will not be given to you directly. Sometimes they will give you radius of gyration. If radius of gyration is given, you can always write I equal to mk square. Many times they will not give you omega of the body. In place of giving you omega, they will give you frequency. So if they give you frequency omega, you will write as 2 pi f. Is it okay? Is it okay? Bol do bhai. So if you have a rigid body which is rotating with angular velocity omega, if its moment of inertia is I, then its angular momentum we define as L will be equal to I omega. If radius of gyration is given, I will be mk square. If frequency is given, omega will be equal to 2 pi f. No problem, no problem. Yeah. So we can write angular momentum of the rigid body very easily. For example, just see here, for example, someone says, sir, I have a rod. This rod is rotating about one of its end. Assume I have a rod. This rod is rotating about one of its end with angular velocity omega. Mass of the rod is m. Length is L. Can you tell me how much angular momentum this rod will have? Someone says, sir, a rod of mass m and length L is rotating with angular velocity omega about one of its end. What will be its angular momentum? So if anyone asks you angular momentum, you simply say, sir, L will be equal to I omega. About end for the rod, you have studied. About end moment of inertia will be ml square by 3 into omega. This is the angular momentum of this rod if it is rotating about one of its end. ml square by 3 into omega. If frequency is given, omega you can write as 2 pi f. Is it okay? Bolo bolo Twarga. No problem. And here I will tell you few more results which will be used from where questions are asked. Just see here, no problem. Yeah, okay. If you remember, now dhyan do, few more results I will tell you. One part of the result will be related with translational motion. Another part of result will be related with rotational motion. Dhyan do, be focused. Just see here. Okay. So always remember, if you remember, some results I will tell you which will help you to do some of the numericals which are asked from here. No concept is there, simply those results are there. So for example, if you remember in translational motion, when your motion was translational, you used to write linear momentum, P equal to mv. Linear momentum of the body you used to write, P will be equal to mv. But in rotational motion, when you write, in place of linear momentum, we talk angular momentum. So angular momentum L will be equal to, in place of mass, we will get moment of inertia. In place of velocity, we will get angular velocity. So linear momentum P equal to mv. So angular momentum will become L will be equal to I omega. The way in translational motion you used to write kinetic energy, that was translational kinetic energy, half mv square. In rotation we write rotational kinetic energy. Rotational kinetic energy will be, come on, tell me what will be rotational kinetic energy? Bolo. When particle translate, you write kinetic energy half mv square. But if body will rotate, rotating body will also have kinetic energy now, but that kinetic energy will be not translational kinetic energy. It will be rotational kinetic energy. So same formula. Here also half, so here also half. Now here m, in place of mass, in rotation we use moment of inertia. In place of velocity we use angular velocity. So rotational kinetic energy will become half I omega square. No problem, yeah. Now if you remember in translational motion, I said you, translational kinetic energy, K will be, we related translational kinetic energy and linear momentum. We studied K will be equal to P square by 2m. So in rotation, we relate rotational kinetic energy will be equal to, in place of linear momentum, now angular momentum will come. In place of mass, I will come. So rotational kinetic energy will be coming as L square by 2I. Arey Baba, same result. Here we use P square by 2m. Here we use L square by 2I. And if you remember there I was saying you, if momentum is constant, if momentum is same, if two particles have same momentum, then I was saying you K1 by K2 will be equal to, momentum same means K will be inversely proportional to M. So I was saying if momentum is same, K1 by K2 will be equal to M2 by M1, inversely proportionally. P is same, K1 by K2 will be equal to M2 by M1. So here we say if L is same, then we say K1 by K2 will be equal to I2 by I1. Is it okay? Everything will be going in a similar manner. For example, there if you remember, I was also saying you, if K is same, already we have done all these things. If K is same, then there I was saying you, P1 by P2 will be equal to under root of M1 by M2. So here also we say if K is same, KR is same, then we say L1 by L2 will be equal to under root of I1 by I2. Same thing we are doing. Are bolo bhai, twarga. If you remember, there we were talking about power due to force. There we studied power due to force. If you remember, power due to force we studied. Force into velocity. Here we study power due to torque. Power due to torque. So in place of force, torque will come. In place of velocity, angular velocity will come. Torque into omega. Same result. One was used in translational motion, other will be used in rotational motion. Are bol do bhai, all these results we have done in translational motion, same results we are converting into rotational motion. So some of the questions are asked where they relate all these things. You can also relate very easily, no problem. Yeah. Is it okay? Okay, Resma. Everyone got the idea? How to convert the result of translational motion into rotational motion? Bol do bhai. Yeah, okay, no problem, no problem, no problem. Yeah. Same thing we can do for force also. If you remember, in the translational motion, you studied average force will be equal to delta P by delta T. In rotational, we study average torque will be equal to delta L by delta T. You can do this relation also, no problem. Yeah, same thing. Or you can say F equal to dP by dt, and you can say torque will be equal to dL by dt. No need to mug up. I'm not asking you to remember. I'm not asking you to remember. I'm just telling you those results we can have in rotation also. Same results we can get for rotational motion also, the results that we got for translational motion. I'm giving you time of 2 seconds, see all this situation, then we will move further. L is not always constant. We will talk about that. Once completed, you can say done, sir. Once completed, you can say done, sir. And once I will say done, sir, you will start saying done, sir. No problem, no problem. Yeah. Okay, no problem. Yeah. Now, now main part. These are the simple results you can relate. Even if I will not tell, you will be able to relate. Nothing to worry, nothing to worry. Now, the main part which we are going to talk here. Main part from where questions are asked in the NEET exam. Just see. Yeah, okay. Okay. So here actually question for angular momentum of rigid body is asked from conservation of angular momentum. The way in translational motion we say now, when net force on the system is zero, its linear momentum will be conserved. In the similar manner in rotation we say, when net torque on the system is zero, its angular momentum will be conserved. Angular momentum will be constant. This is known as conservation of angular momentum. And numericals from here are asked. They will ask you numericals for angular momentum of rigid body. They will always ask you from conservation of angular momentum. Now you can write conservation of angular momentum. Conservation of angular momentum. Conservation of angular momentum. Conservation of angular momentum. And you write, if net external torque, this is the statement, if net external torque acting on a system, if net external torque acting on a system is found to be zero, if net external torque acting on a system is found to be zero, then angular momentum of the system, if net external torque acting on a system is found to be zero, then angular momentum of the system will remain conserved, that is constant, If net external torque acting on a system is zero, then angular momentum of the system will remain conserved, that is constant, So always remember, if external torque acting on the system is zero, then angular momentum of system will remain conserved. Angular momentum of the system will remain conserved means angular momentum will remain constant. Why I am saying like this? Because just now you studied torque will be equal to delta L by delta T. Just now I have written torque will be equal to delta L by delta T. Someone says, sir, if this torque on the body, torque means here we are talking about external torque. If someone says, sir, if external torque acting on the system is zero, if your external torque is zero, if you put external torque here zero will be equal to delta L by delta T. That means from here you can say delta L will be zero. Delta L will be zero means change in angular momentum is zero. Change in angular momentum is zero means angular momentum will be constant. Angular momentum will be constant means I omega will be constant. I omega will be constant means I1 omega 1 will be equal to I2 omega 2. That also means due to some internal reason, if I will increase, omega will automatically decrease. This is our conservation of angular momentum. CO, conservation of angular momentum. Just now we studied torque equal to delta L by delta T. If torque is zero, that means delta L will be zero. Delta L will be zero means change in angular momentum is zero. Change in angular momentum is zero means angular momentum is constant. Angular momentum is I omega. So I omega will be constant. That means I1 omega 1 will be equal to I2 omega 2. If due to any internal reason, external agent not required, if only internal things are there, if due to internal reason, if I will increase, omega will automatically decrease. Or if I will decrease, omega will automatically increase. Is it okay? Is it okay? Is it okay? Bol do bhai, bol do, come on. I omega will be constant. If one will increase, other will automatically decrease. Yeah. Now from here, theoretical questions are also asked, numerical questions are also asked. Mainly numerical questions are asked, but some theoretical questions are also given in the NCERT. So dhyan do, we'll cover up those theoretical questions in 5 minutes. Dhyan do, just here. Yeah, okay, no problem, yeah. Okay. Achha, you may have seen some ballet dancers on the TV. You have seen when ballet dancers will keep their hand unfolded, their omega will be less. But when they will fold their hand, omega will automatically increase. Can you tell me why? You may have seen ballet dancers when they will dance and when they will revolve like this, when their hands are unfolded, omega will be less. But when they will fold their hand, automatically their omega will increase. Because when they fold their hand, I decreases, angular momentum will be conserved. There is no external agent present there, no external agent is there, no external torque is there. So if external torque is not there, angular momentum will be conserved. So what happened when they fold their body? When they fold their body, I decreases, or distance from axis will decrease. Now I will decrease, omega will automatically increase. You can write this, come on. Or you may have seen some gymnast. When they jump from some height or when they go in air, they fold their body. Once they fold their body, their omega increases, their rotation increases. You may have said, yeah. Yeah, okay, no problem. Yeah. So whenever, so you can write this. Come on. You may have seen some gymnasts or some people jumping from large height into water. While falling, they will fold their body completely. When they will fold their body, they will start rotating in air. They will start rotating in air. So why their angular velocity increases? Because their moment of inertia decreases. You can write this point. Come on. You write? Yeah. During swimming, diving only. That is what I am saying. Yeah. Okay. You write? Whenever, okay, no problem. Yeah, you're right. Whenever any ballet dancer or gymnast, fold their body, yeah, I have already done all this thing. Yeah. Whenever any ballet dancer or gymnast fold their body, I decreases, and hence omega increases. And hence, whenever any ballet dancer or gymnast fold their body, I decreases, and hence omega increases, because angular momentum is conserved. In bracket, constant. Sometimes they ask which quantity will increase, which quantity will decrease. So I will decrease, omega will increase, but one thing will not change. Can you tell me what one thing will not change? Here, which quantity will not change for the body? And this also NEET 2019 question. They said one sphere is there. This also one question came. They said one sphere is there and they said sphere is rotating with angular velocity omega. They said, if this sphere expand, yeah, okay, L will remain same. Very good, yeah. Question was asked like this. Just see, they said, one sphere made up of metal is present in a room. This sphere is rotating with angular velocity omega. Then they said, if temperature of the room is increased, you tell me if you increase the temperature of the room, if temperature of the room will be increased, if you increase the temperature, if temperature is increased, your sphere will expand. If your temperature of the room is increased, if temperature is increased, your sphere will expand, radius will increase. If radius will increase, I will also increase, because you know I will be proportional to mr square. If I will increase, omega will decrease. But one quantity will not change due to all of these things, that is your angular momentum. Angular momentum will remain constant. They asked in the NEET exam, if radius of the sphere is increased, which quantity will remain constant? And that quantity is your angular momentum. If you don't fold, you will not rotate. Your omega will not increase. Manas is saying, sir, if I don't fold, nothing will happen. It will remain as it is. Is it okay? Bol do bhai, bol do, come on. Then one more theoretical question. Okay, no problem, yeah. So if you increase the temperature, sphere will expand. Sphere will expand means radius will increase. If radius will increase, moment of inertia will increase, omega will decrease, but angular momentum will remain constant. In all this situation, angular momentum will remain constant. Now dhyan do, see the next question, next theoretical question only. Just see. Okay, no problem. Yeah, okay. One question is very famous, which is asked. Just see, yeah. You know, right now, dhyan dena, be focused, yeah. You know, right now, global warming is going on. And on Earth, you have huge amount of ice present at the poles. So due to global warming, this ice is getting melted slowly. It will not melt in one day. This ice is getting melted slowly. It is converting into water. And that water, due to gravity, will collect on the equator. So question is asked, if all the ice, you can write this question, come on, and you will tell, come on, you write. If due to global warming, ice present on the pole, if due to global warming, ice present on pole, if due to global warming, ice present on pole melts and gets collected on the equator. Yeah, Larry, correct, Sam, correct, yeah. If due to global warming, ice on the poles gets melted and collected on the equator, what will be its effect on duration of days and night? What will be its effect on duration of days and night? What will be its effect on duration of days and night? What will be its effect on duration of days and night? So duration of days and night will increase or decrease. Right now duration is 24 hours. It will become less than 24 hours or more than 24 hours. It will increase, Baba. It will increase. You will simply say, see here, no problem. Dhyan do, just see here. This is what will happen. Actually, right now, if you look at Earth, this is the axis on which Earth rotates. This is the axis of rotation of Earth. Right now, ice is present on the poles. Right now, ice is present on the poles. Yeah, okay, no problem. Yeah. Right now, ice is present on the poles. Due to global warming, this ice will melt and this ice will collect on the equator. Due to global warming, this ice will melt and this ice will be collected. This ice in the form of water will be collected on equator. Now if you look at here, initially, okay, no problem. Yeah, dhyan do yahan pe. If you look at here, you'll find initially all the ice is present close to the axis. So moment of inertia of the earth is lesser. But when ice will melt, water form will be located at more distance from axis. So here what will happen? First, I will increase. If I will increase, omega will decrease. And always remember, we are not talking about omega, we are talking about time period. So you know omega will be equal to 2 pi by t. So if omega will decrease, your omega is inversely proportional to time period. If omega will decrease, your time period of revolution of earth on its axis will increase. And this time period is known as duration of days and night on earth. So if time will increase means duration of days and night will increase. Duration increases, it will become more than, duration increases, it will become more than 24 hours. Is it okay? समझ में आया क्या? And right now all the ice is on the axis. As the ice will melt, okay, maybe that is also a possibility. Yeah, okay. Right now all the ice is present on the axis. When ice will melt, from axis distance will increase na baba. It will go to equator na baba. So distance from axis will increase na. If distance from axis will increase, you know I is proportional to mr square. R will become more. If distance will increase, I will increase. If I will increase, omega will decrease. Omega will decrease means duration of days and night will increase. We are talking about rough idea, Jonathan. We don't require exact value of R. Yeah, you'll get more time to prepare. No problem. Yeah, I'm giving you time of 2 seconds. See all these theoretical questions completed. Now we'll do one type of numericals which are asked from here. 3-4 types of numericals are there. Those all 3-4 types we'll talk. I'm giving you time of 2 seconds. See all these situations. Come on. Is it okay? Is it okay? Everyone understood these 2, 3, 4 theoretical questions? No problem. Now we'll start with numericals. Yeah. And one type of each numerical I will talk. Yeah. So that you will get idea. No problem. Yeah. You write first question. Come on. You write one question. If due to some internal reasons, Earth expands. If due to some internal reasons, Earth expands to double its radius. If due to some internal reasons, Earth expands to double its radius, what will be new duration of days and night on Earth? If due to some internal reasons, Earth expands to double its radius, what will be new duration of days and night on Earth? Right now duration is 24 hours. Radius will become double. That means moment of inertia will become 4 times. Means omega will become 1 by 4. Means time will also become 4 times. 4 times of 24, 96 hours. That's a very good thing. You'll get more time to prepare. Radius became double. Earth expands to double its radius. Shyam, don't do mistake. Simple question. I will simply say, sir, you are saying due to internal reason, Earth expand to double its radius. That means right now, radius of Earth is R. If double the radius, means radius will become 2R. That means 96 hours will come. See here, see the process, no problem. Dekh lo ek baar, dekh lo. Do the next question, no problem. This is what they are saying. If due to some internal reason, Earth expands to double its radius, means initial radius of Earth is R. Now this radius became 2R. If radius became 2R, that means moment of inertia will become. If radius became double, I will become from I. Your I, I will be proportional to R square. So if your radius became double, your moment of inertia will become from I, it will become 4I. And if your I became 4I, that means omega will become, from omega your angular velocity will become omega by 4. Your new angular velocity will become, Reshma, correct, okay, no problem. Sir, if moment of inertia became 4 times, angular momentum will become 1 by 4. This is what I said you. I into omega will be constant. If 1 becomes 4 times, other will automatically become 1 by 4 times. And if your omega became omega by 4, that means, and time period, omega is inversely proportional to time period. So if your omega became 1/4, time period will become 4 times. Are Baba, inversely proportional, 2 pi by t. 4 times means this is our new time period. That means new time period will become 4 times of 24 hours. It will become 96 hours. Out of 96 hours, 80 hours you will sleep. Are bol do bhai. Or if you want, you can do like this also. Sir, new angular velocity omega dash will become, sir, omega by 4. That means omega dash we can write, sir, 2 pi by t dash. This will be equal to, sir, 1 by 4 of omega. Omega will be, sir, 2 pi by t. And this t is 24 hours. So 2 pi cancel. Your t dash will come 96 hours. Is it okay? Bol do. Come on, Twarga. Bolo. Or very less people are saying. Is it okay? Easy question, Baba. 90 hours study, sir. Do the next question. Come on, do the next question. Same type of question I will give you. Come on. You write. If due to some internal reasons, this time everyone must get the answer. If due to some internal reasons, Earth contracts to half of its radius, if due to some internal reasons, Earth contracts to half of its present radius without changing mass, find new duration of days and night. Find new duration of days and night. Now it will come 6 hours. Now it will come 6 hours. Very good, very good. Now people are giving. I will simply say, sir, radius r, this will become r by 2. That means moment of inertia I will become I by 4. That means omega will become, from omega will become, moment of inertia became 1/4. So omega will become 4 times. If omega will become 4 times, time period is inversely proportional to omega. So new time period will become T by 4. T by 4 means 24 by 4. That will become 6 hours. All these 6 hours you will use for sleeping. No problem. Yeah. Is it okay? Is it okay? Can I be 100% sure you will be able to do such question? Come on. Everyone will be able to do. Bolo bhai. If you want to do with entire steps, someone says, sir, I will solve with formula, then you have to do like this. I1 omega 1 will be equal to I2 omega 2. Yeah, then you can put the value of I1, I2 and you can get no problem. You can do like this. This is better. Yeah. Jonathan, what about aging? No problem. We'll discuss that later on. Now I'll give you next question. Come on. This is first type of question which we can do very easily. Now see next type of question. See next type of question. Just see here. Just see here. Dhyan do. Just see here. Just see here. Okay. No need to study. 3 days sleep, 1 day study. Only days of 3 hours, 6 hours now. So 3 days sleep, 18 hours. Now also you sleep. 18 hours sleep and 6 hours study. And next 6 hours bhojanam. 1 day bhojanam, 1 day sleep, 1 day study, 1 day movies. Okay, no problem. Time is not there. Still 2-3 types of numericals are left. एक बार देख लो. Just see here. Yeah. Okay. No problem. ध्यान दो. Just see here. Yeah. Okay. Now next type of question which is asked from here. Second type of model. ध्यान दो. This type of model has been asked 4-5 times in our NEET exam. एक बार ध्यान देना. Be focused. Just see here. Yeah. See how question is asked from second type of situation. In second type of situation, they will say you like this. This is the most important question. They will say you like this. Just see. Yeah. Okay. For example, they will say you. Assume I have a ring. Tomorrow they can say about disc also. But whenever question is asked, generally they ask you for ring only. Assume I am having a ring of mass m and radius r. I am having a ring of mass m and radius r. They will say this ring is rotating about its geometrical axis with angular velocity omega. They will say a ring of mass m and radius r is rotating about its geometrical axis with angular velocity omega. Or you can say with initial angular velocity omega naught. Yeah. Now they will say if on the ring if I attach two small particles, they will say if on the ring two small particles are attached, if I attach two small particles each of mass m on the ring, what will be its new angular momentum? You will simply say, sir, initially, what if you attach two particles on the ring? What will happen to new angular velocity of the ring? Once you attach two particles now, moment of inertia of the ring will increase. Because now these particles will also rotate with the ring now. Moment of inertia will increase. If moment of inertia will increase, omega will decrease. So they will ask you find new angular velocity. You will simply say, sir, I know, sir. I1 omega 1 will be equal to I2 omega 2. Initially who is rotating? Initially who is rotating? Only ring is rotating. Initially who is present, Baba? Only ring is present. So what is initial moment of inertia? Due to ring, mr square into angular velocity omega naught. And when you attach the two particle, yeah, very good. Remant, very good. Yeah, okay. Vamshi, very good. No problem. Yeah. Sam, you cannot say masses are not equal. One is small m, one is capital M. Now they will say, if you attach two particles on the ring, now who is rotating? Ring is already rotating. Still ring is rotating. And particles are also rotating. So total moment of inertia will become due to ring mr square plus due to particle. Two particles are there. Each particle distance from axis is r. Each particle distance from axis is r. For particle, you remember moment of inertia mr square. That is 2m into r square into omega dash. Now from here, r square cancel. You can find omega dash. Omega dash will become m omega naught by m plus 2m. अरे बाबा समझ में आया क्या? Did you got the idea? Tomorrow in place of ring, they may put a disc also. They will say disc is rotating. If disc is rotating, here mr square by 2 will come and here also mr square by 2 will come. Depending on situation, they can give you disc also. If they will give you disc, here you will put mr square by 2. Here also will put mr square by 2. You can write the next question. Come on. You do the next question. Yeah. You can write. Yeah. Are two particles are there, Akash. For each particle moment of inertia. Are finally ring also rotating, particles also rotating now. So one part, arey baba, yeah, one particle mr square, other particle also mr square. So two particles, that's why we are getting for this. This is the moment of inertia for the particles. 2mr square. This is the moment of inertia of the ring. Finally, ring will also rotate and particles will also rotate. So new moment of inertia total you have to see. Total moment of inertia will become mr square plus 2mr square. Bolo bolo, done. You write in the above question. You write, come on, in the above question, same question, in the above question, if four particles are attached to the ring, in the above question, if four particles are, this is also previous year NEET question, in the above question, if four particles are attached to the ring, find its new omega. Very good, Remant. Yeah. Find its new omega. If you attach four particles, again you will say, sir, I1 omega 1 will be equal to I2 omega 2. Again you will say I1 omega 1 will be equal to I2 omega 2. Sir, I1 omega 1 means initially, sir. Initially only ring was rotating. So moment of inertia of the system was mr square into omega naught. Finally, I2 omega 2 means final. Finally, who is rotating? Sir, ring is already rotating, mr square. Plus 4 particles are now rotating. So 4m into r square into omega dash. R square cancel. Your omega dash will come m omega naught by m plus 4m. अरे हो जाएगा क्या? बोल दो भाई. त्वरगा. Is it okay? हाँ, this time 4m r square. Yeah. And be careful about ring or disc. You tell me if disc is given. They are not saying ring. People always take for ring. Sometimes in the exam they play with student. You are studying for ring, they will give you disc. Then what you will do? Come on. If disc is given, where is the change? If disc is given, where is the change? Jaldi batao. If disc is given, where is the change? If disc is given, where will be the change? In place of ring, if I give you disc, where you will do the change? जल्दी बताओ. हाँ, here mr square by 2. Here mr square by 2. Remaining concepts will be same. Yeah. Then you can do the calculation and you can get. No problem. Yeah. Now we'll move towards. Yeah. बहुत बढ़िया. Yeah. Okay. No problem. Yeah. हाँ. Now we'll move towards. Yeah. mr square by 2. Yeah. Now we'll move towards third type of numerical which is asked from here. You can write coupling of disc. in bracket CBI NCRT. If 10 times question has been asked from conservation of angular momentum, 6 times question has been asked from coupling of disk. So most important part, yeah, coupling of disk. Coupling of disk. Coupling of disk in bracket CBI NCRT. If you see previous year NEET question, all the questions will be filled with this part. Coupling of disk. Now ध्यान दो, easy only. ध्यान दो, be focused, understand, just here, no problem, yeah. अच्छा, assume one disk is rotating. Assume one disk is rotating with some angular velocity. अच्छा, over that rotating disk, if you couple another disk, if you put another disk, what will happen? One disk is rotating with angular velocity omega. Over that disk you have put another disk. What will happen? Can you tell me? If you put another disk over a rotating disk, what will happen? In the beginning, system will be disturbed, but you will find after some time both disks will rotate together as a single body, just like perfectly in elastic collision. Dhyan do. Be focused. This is how things happen. Yeah. For example, assume I have a disk. This disk is having moment of inertia I1, rotating with angular velocity omega. Yeah. Okay, no problem. Yeah. Assume I am having a disk of moment of inertia I1 rotating with angular velocity omega. I said, sir, I have another disk. Sir. This another disk has moment of inertia I2. But initially its angular velocity is 0. Initially it is, yeah. Of course friction will be there. Yeah. Initially, sir, this disk is not rotating, only this disk is rotating. If you couple them, you will find that finally they will behave as a single body. Dhyan do. If you couple these two disks, you will find that finally they will rotate with cos, yeah. They will rotate with same angular velocity. Question is asked to find that final angular velocity. Right now one is rotating, other is not rotating. If you couple them, in the beginning system will be disturbed, but finally you will find that both will rotate with common angular velocity omega, and both will behave as a single disk whose total moment of inertia will be I1 plus I2, and it will rotate with some angular velocity omega dash. Question is asked to find this final angular velocity. You can find very easily because you know initial angular momentum. For this disk, I1 into omega. I will simply say initial angular momentum will be equal to final angular momentum, sir. What is initial angular momentum, sir? I1 into omega plus 0. This disk is not rotating. Finally, they will rotate as a single disk whose total moment of inertia will be I1 plus I2 into omega dash. So from here we can find omega dash. Omega dash will come I1 omega by I1 plus I2. Is it okay? Bol do bhai. Twarga. Yeah, definitely friction will be there. We will talk about it also. एक बार जल्दी बता दो त्वरगा. Sometimes these are not formula. Don't remember them as formula. Is it okay? Concept is finally they will behave as a single disk whose total moment of inertia will be I1 plus I2, and they will rotate with same angular velocity omega dash, which you can find very easily. Sometimes questions are asked like this also. Dhyan do, be focused. Just here. Yeah. Okay, no problem. And always remember, due to coupling, there will be always loss in kinetic energy. This is what you are saying, sir, friction will be there. If suddenly you put some heat will be also there, sound will also come. So there will be always loss in energy due to friction. So sometimes questions are asked, find the loss in energy which happened due to friction here. So for finding loss, you will calculate initial rotational kinetic energy. So what is initial rotational kinetic energy? Due to this disk, half I1 into omega square. Due to second disk, 0. Final rotational kinetic energy you can find, sir, half. Finally, two discs together. Now this is one disc having moment of inertia I1 plus I2. I1 plus I2 into omega dash square. Omega dash square. And if you have initial rotational kinetic energy, final rotational kinetic energy, you can put omega dash here. You can find loss in kinetic energy. Loss in kinetic energy means kinetic energy, rotational kinetic energy initial minus rotational kinetic energy final. We will talk about that, Kusma, don't worry. Yeah. Did you understood how to find loss in kinetic energy? अरे बोल दो भाई, बोल दो कौन तोरगा जल्दी अरे if you know initial I, if you know omega, you can find initial kinetic energy now, you can find final kinetic energy now, from there you can find loss now. Initial kinetic energy was 10 joule, final was 6 joule, so what is loss? 10 minus 6, that is 4 joule. Now sometimes what happens, now be focused, so many situations are there. Yeah. Okay. Achha, right now, be focused. Right now I'm saying, sir, one disc is rotating, other disc is not rotating. But sometimes questions are asked like this, sir. Assume both discs are rotating. This disc is I1 rotating with omega 1. Another disc I2 rotating with omega 2. Now if you couple, then what will happen? Bolo. What will happen if you couple now? Again, if you couple, they will rotate as a single disc, whose total moment of inertia will be I1 plus I2. And now your system will rotate with angular velocity omega dash. So question is asked, now if you couple, what will be final angular velocity of the combined disk system? Again you can find, sir, initial angular momentum I can find, sir. What is initial angular momentum due to these two disks? I1 omega 1 plus I2 omega 2. And what is the final angular momentum, sir? I1 plus I2 into omega dash. So again you can find omega dash. Omega dash will come I1 omega 1 plus I2 omega 2 by I1 plus I2. Arey baba, bolo. Torga. If anyone asks you loss, again you can find loss. Again you can find initial kinetic energy. So initial kinetic energy will come due to this disk. How much it will come, sir? Half I1 into omega 1 square plus half I2 into omega 2 square. What is the final rotational kinetic energy, sir? Now two disks are there. So half I1 plus I2 into omega dash square. Again loss you can find kinetic energy initial minus kinetic energy final. Arey bolo bhai, bolo. Is it okay? Is it okay? All possible situations I am talking. Concept already I told. जल्दी बोल दो भाई. अरे initial total will be equal to final total. That's it. Initial angular momentum will be equal to final angular momentum. That's it. Sir, why kinetic energy will be lost? Because friction will be there. Friction will do some work. That friction will bring loss in energy. Okay, Akash. Yeah, okay, no problem. Achha, you tell me, is it mandatory that both discs will rotate always before coupling in the same direction? Right now I'm taking, sir, here also omega 1 same direction, here also omega 2 same direction, but you tell me, sometimes possibility is there now. Someone said, sir, omega is in this direction, omega 1 is in this direction, omega 2 is in this direction. Can you tell me now what will happen? Now also if you couple, both will rotate together with the common angular velocity omega dash. Now they will have total moment of inertia I1 and I2. But tell me, where will be the change? Where will be the change? If both discs are rotating in opposite direction, where will be the change? Where will be the change in this result? बताओ कहाँ change करोगे? Where will be the change now? अरे बाबा, here you have written I1 omega 1 plus I2 omega 2 now. You have written plus because both are rotating in the same direction. If they will rotate in opposite direction now, initial angular momentum you write I1 omega 1 minus I2 omega 2. And finally they will rotate together. I1 plus I2 into omega dash. So again you can find omega dash, that will become I1 omega 1 minus I2 omega 2 by I1 plus I2. अरे कुछ समझ में आया? अरे वेक्टर क्वांटिटी ना, एंगुलर मोमेंटम, angular momentum vector quantity, here not minus, here not minus, moment of inertia is not vector quantity, here not minus, finally total moment of inertia I1 plus I2, only negative will come in the numerator, not in the denominator. समझे क्या? बोलो 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 बोलो, come on तोरगा. So this is how we talk about, yeah, okay. Now I'll send you homework in the afternoon, do the homework, then you'll get better idea. Kinetic energy again, for kinetic energy no need to do minus. Kinetic energy has nothing to do with direction. Again initial kinetic energy half I1 omega 1 square plus half I2. Again you can find change in kinetic energy, no problem. Arey baba, you can find the initial half I1 omega 1 square plus half I2 omega 2 square, that is the initial. Total final half I1 plus I2 into omega dash square. Again you will get, no problem, no problem. So this is how we have talked about. More situations from here we'll be talking in our next class. For today we'll be ending here, but must do homework after the class. I'll send you question, you must practice, then only you'll be able to do in the NEET exam. For today we'll be ending here only. Okay, bye bye, tata, bye bye.